is Jake Freivald from Fulcrum, and today we'll be talking about future-proofing field data and making a business case for a field process platform. It's actually got a lot of really interesting material in it, I think, and so it's worth starting off by talking about what our goal should be here, and that is to understand why GIS platforms, and others as well, enterprise asset management, et cetera, but I'm going to focus a lot of time on GIS today, why those platforms are different from field process platforms, and how that difference affects architectures for fieldwork. In other words, we're not just going to talk about the goals that field teams have, but how we have to let our technology and our architectures conform to the structure necessary to achieve those goals, right? So we'll be talking about that, and it's going to be a bit of a conversation to get there. That conversation is going to include the following 4 types of things. First, we'll talk about the different types of teams that we are, why a GIS team is different from a field team, and why their needs may be somewhat different, and how potentially, although they are different teams with different needs, they have one goal to reach, or they have one consistent set of goals. That's going to lead us to think about what the differences are in our design for the platforms that they use, and considerations for how other new and emerging technologies might fit into those platforms. And of course, with all that in mind, then we have to talk about what the implications are for the architectures that we use to support these different kinds of teams. So with all that in mind, let's get started by talking about those different teams and their different needs, but the single set of goals that they have. And we'll do that by just contrasting what they focus on. So we'll start with the GIS team and think about, first of all, the kinds of information they collect. If you look at your typical GIS, it contains a very complete database across all parts of the organization, because they are typically a corporate-wide resource, of all the geospatial entity data. So if there's an asset out there, we need to know about it. If there is a piece of land out there that changes how we interact because we own it, or because it's part of a particular jurisdiction or something like that, then we know about it. All of those different entities are in that database. Those of you who've been around databases for a long time may know that one of the ways that you design a database is through an ER diagram, right? Entity relationship diagram. And that makes me think about the stuff that we're capturing in the GIS in terms of the nouns that we use in our sentences, right? So, and these are corporate, like I said, because they're corporate level. The GIS team is a corporate level resource. So we think about the nouns that we use in a sentence. The following kind of asset is in the following location, and because that's in that location, I can do some things with it, right? So it's the corporate nouns related to our business. One of the other things that the GIS team does really well is focus on multi-source data. So they're really focused on bringing together all of the information that may be necessary to help people make decisions. In the case of something like, let's say, an emergency response team, supporting an emergency response team, they may be really focused on the geographic boundaries, the political boundaries, such as am I working in this town versus that town? Are there different kinds of demographics associated with that town? Because I know that I want to make sure that I'm treating parts of my jurisdiction appropriately, regardless of how they are, the demographics in them. If they're rich or poor or whatever it may be, we want to make sure that they're being treated equally, right? So I'm going to bring together that information along with the information about the resources that are there that I'm working on, whether it's the set of power poles that I'm working on, the transformers that I'm using, et cetera, right? All of that information has to be there too. So bringing together information to synthesize the data is a really critically important thing. And that makes them focus on the structure of the data. How can I structure my data in a way to get consistent analysis throughout all of the work that I do? And analysis is the key word there. Very often the GIS team spends most or all of its time doing the preparatory work with the data on the structure, the cleansing, and all that kind of good stuff to get the data to the point where they can do the second thing they spend all their time on, which is analysis, right? It's all about getting the data ready for analysis, or actually doing the analysis itself and creating the maps that are able to tell us in such a compelling way what the state of the world is. So given all of that, what that makes them do, what a GIS team do, is think in terms of the fields that are in a layer and the layers that they have. It could be related tables and other stuff too, of course, but simplifying slightly, they think in terms of the fields that they're dealing with and the layers that they are accumulating to be able to tell that story to the people who need that geospatial knowledge. So just summarizing: complete database, the corporate nouns, multi-source data, thinking in fields and layers. Let's take a look now at the field team and think about how they think, because it's pretty dramatically different. The first thing that the field team is concerned with is the documentation of what they have done, right? So it's not about the things, it's about the things they have done, and it's about the things they have done. They are not they're a corporate resource in the sense that they support what the corporation's objectives are, but they are not, on loan to various parts of the corporation. They are focused on their specific tasking. So the field team is really not about the nouns, it's about the verbs. I inspected the following thing. I did the following preventive maintenance. I installed the following piece of equipment, right? They're the verbs of the sentences. So you can see that GIS and field are complementary, but they're definitely not the same thing. They focus on different things to some extent. That focus being on is on in-scope task data. So much smaller scope than the corporation. It's really about what I need right now. I'm standing in front of a transformer at this moment. What do I need to know? And when I'm done with that task, what does everyone else need to know that I did to give proper proof of work? That proof of work is really critical. Documenting, the fact that I did everything successfully, correctly, that there's not going to be a spark as a result of this, or a wildfire as a result of this, or contamination of the environment as a result of this. That in-scope task data is really important to the field team. It's the primary thing that they need. So think then in terms of process requirements. What do you have to do? And potentially when you're making decisions, you're doing operational decision making. So it's actually kind of interesting. If you think about the GIS team as being more analytical and the field team as being operational, that's pretty close. But again, there's a really strong complementarity there. The GIS team is analytical when it comes to making sure that you know where to go in the event of a power outage, right? If you've used, for example, if you use ArcGIS, you may be familiar with the utility network, which is a solution they have that includes a data model and a set of digital services basically that surround that data model. So you can look at something and say, okay, I've got an outage in this area. Where's the likely problem? You can trace where the problem is likely to be. Or you can say, if I have a storm coming in and I expect there to be a major problem with this substation, then you could say, okay, well, what does that substation affect and how can I route around it potentially? So they're thinking about operations, but they're doing analysis to support the operations. Whereas with the field team, they're thinking about what they've got to do operationally, and the analysis that they do is related to the specific tasks that they have on hand to do it. So it's just a different mindset, but complementary again. And so with that in mind, then that makes us recognize that they think not in terms of fields and layers and things like that, but in terms of the steps they have to take in order to complete their work orders. So these are very strongly different mentalities. And I think that's one of the reasons that GIS teams and field teams sometimes have difficulty communicating or sometimes have difficulty understanding why the other wants what they want. But we do recognize that they want the same things, right? If you ask them what they're looking to do, they will definitely tell you that they're interested in the safety and the reliability and the resiliency and all the other things that corporate goals contain, right? They want all of that same stuff. Regulatory compliance is huge for both of them. Again, one making sure that I've got the process down to make sure I'm complying, and the other saying, okay, well, I can look and see where there could be regulatory compliance problems, that sort of thing. Organizational efficiency, customer satisfaction, effective budgeting. There's no question that both of these very different teams are trying to pull toward the same goal. The question is, how can we then support both of them with technology in a way that's going to make each one competent and capable on its own, while also sharing information in a way that's highly complementary, so that the complementary aspect of what they do is going to be fully achieved. So That's the study in contrasts. And the major question that I think we need to answer, and I'm going to spend a lot of time answering that question over the course of the next 30 minutes or so. So let's talk about the way that you support an organization using a platform, and we'll focus on the way that current platform exists for GIS team. Okay, and then we'll talk about the differences between that and what the field teams need. If we think about what a GIS platform does, we have to start by saying what it does for the GIS team itself. So what is a platform for is our first question. I submit that there are three major things that a platform does. Any platform of any type, this is true of enterprise asset management, ERP, you name it, there's a business owner of that platform, and that business owner is responsible for standardizing specific processes and data. And the platform is where that standardization takes place, right? So again, your GIS is going to do that for all of the geospatial entities within that are relevant to a corporation. An enterprise asset management platform, same thing. I know where all my assets are, and this is the way that I manage them. This is how I do reporting on them, and so forth. With a safety management system, you might have the same kind of thing. How do I standardize my safety practices, and so on and so on and so on. So this is true across the board. The same thing is true for the next ones. Customizing according to business needs. Well, not every business need is exactly the same. The stuff that you need to capture in Oklahoma might be significantly different from what you need to capture in California. And that'll be true for safety and assets and GIS, et cetera, et cetera. All of those things are going to be somewhat different. Similar, but somewhat different. You need to customize what you do according to those specific business needs. There are also potentially processes, for example, of loading the data into the GIS. We'll talk about that more in a second. But loading the GIS into the data into a GIS might require a different approach using some types of data versus other types of data. Well, how do I standardize and customize those? And that leads to the third bullet, which is integrating with other systems. The business owner of that platform says, if I need information from you, I'm going to get it and put it into my platform. And if you need information from me, you're going to get it from my platform. You're going to make a request to me to get it from my platform. So the standardization, customization, and integration of your processes and data is what a platform is for. And that's what a GIS platform does as well. The requirements that we've talked about for the GIS team include things like the speed of analysis. It has to be structured in a way that I can get great geospatial analysis very quickly. Data unification, because as I said, they're working with multi-source data to get that really comprehensive understanding of what's happening in the world. And data consistency is very important because they're doing a lot of analysis over time, and they need to make sure that that data is consistent across the board. Those requirements lead to specific processes that take place in the GIS platform, including defining, loading, and refreshing the layers and related tables that are important to the GIS team's customers, usually internal customers, but could be external customers as well. They have to define, load, and refresh those layers. That's some of the processes that they need to do. And then they need to do the analysis and so on top of that. And that is what leads to the actual set of data that we get in a map that tells us precisely the fact that two of these poles are inside a fire boundary and two of them are outside the fire boundary. You wouldn't know that without the GIS platform being able to do what it does and synthesize that information. If you take the GIS and say, let's apply the GIS to a field context, and this happens all the time. This is a very, very common thing to do. The GIS team says, okay, we are in support of the field in the following way because the field team is so geospatially oriented. We have to think about what this actually means. The field requirements include things like operational speed over a limited scope, right? So that's a little different from what the GIS team is normally concerned about. They are required with process rigor and fast adaptation. What do I mean by that? I mean that your environmental inspection, or we've got a customer who does balcony inspections in apartments, right? That kind of inspection could have different regulations in, again, Oklahoma versus California. So if I get a new customer in California, I need to very quickly adapt my process in California to fit their regulations. Having said that, in both places, I need absolute rigor with respect to what I'm trying to accomplish, to doing those kinds of inspections. So process rigor, absolutely having that process rigor, but making sure that it's not static. It's something that I can change along with customer regulatory and other requirements. And then finally, it's very cross-functional. If you think about what a field team does, they're going to roll out a truck. That's frequently something that's done inside the field service management application. You know, this person and that person are going out on a two-team outing today, and they're going to be using truck number 1, 2, 3, 4, et cetera, et cetera. Then they get on site to perform some maintenance on a transformer. And when they do that, they have to do a shutdown, a lockout tagout of that transformer before they begin work. That's a safety requirement that if you have a safety management system, then that would go in there. If not, it's something that just needs to be built in somehow. Then they're going to perform that maintenance. And the maintenance is important for both the enterprise asset management team, who needs to know about the maintenance, as well as for the GIS team, who also probably collects some of that information, knowing when it was last, a piece of equipment was last installed, verifying that it was safe, verifying that it was functioning properly, and so on. So that's probably actually dual responsibility there to the EAM team and to the GIS. So this is a very highly cross-functional set of requirements that the field team has. And if you think about what the GIS does, then there are going to be issues with supporting it if you only have the GIS to do that. Here's the kind of adaptation that you need in order to support the field. First, you need to do rapid data updates. That's generally speaking not so bad. GIS is very good these days, Esri ArcGIS being the dominant one. There are some other smaller platforms you might use as well, but they're generally pretty good at absorbing data in a real-time kind of a way. So that's okay. The process rigor is challenging though, because process rigor is not a challenge. Being able to do a process over and over and over again in exactly the same way is not so bad with the GIS. But the GIS is frequently focused on the entity, not on the process. So you're collecting data, but how you collect that data or what data relationships there might be as part of the process that you go through might not be easy to capture. And the adaptation is really difficult to do, because anytime you make a change, if you go from California to Oklahoma, then you're going to make changes in the layers and the related table structures, and then when you're doing data loading processes, you need to change how that data is flowing into the platform. And GIS is not designed to do that, generally speaking. It's just different from what the field normally would need in that situation. And similarly with cross-functional information, there's going to be a lot of stuff in this process that the GIS team simply doesn't need, right? If you don't have a field safety service management platform, you need to store where the truck was rolling out and in the GIS somewhere. You don't want to do that. The lockout tagout, there's no reason for a GIS to keep information about the safety steps that took place before a piece of preventive maintenance. All the GIS needs to know is that the maintenance was done on such and such a date. The equipment that came along with those trucks, et cetera. Why would I ever want to store any of those things in my GIS? So that cross-functionality, if you're just trying to support the field with the GIS, that cross-functionality is a bit of a mismatch. And so I hope I've made it clear that there's nothing wrong with the GIS. It's just that it's not designed to handle field processes. So I'm going to go through a couple of statements. The issue isn't this thing over here, it's that thing over there. The job here is to separate out what a GIS is designed to handle versus what it's not designed to handle. And GISs are designed to handle rapid updates, so we don't have that issue. But they're not designed to handle rapid updates to data structures. That's not something that the GIS typically does very well. The GIS is designed to handle a lot of data sourced from the field. That asset management data, for example, I was talking about nouns of the corporate nouns that it collects on. It's designed to handle high volumes of data from the field, no doubt. But it's not designed to handle all the types of data that the field collects. And I don't mean data types in the technical sense. I don't mean video and photos and stuff like that. I mean the safety data is not designed is not something that the GIS has been designed to handle. It's not a problem that the GIS teams want to help the field get important data. I was actually at the Esri user conference this year, and one of the consistent things that I heard is how much the field wants to help the GIS team. We're going to talk. Pardon me. The GIS team wants to help the field, and I'll talk a little bit about more about that in a minute. But The problem is that the GIS isn't designed to hold the process data that field teams need. So the GIS team can want to help as much as it can, but if it's not holding the process-based data, here are the individual step-by-step, steps that you take in order to implement a task, in order to get that task done in the appropriate way, then the field team can't properly help the field team do that aspect of what they need to do. And frankly, like it says here, nor should they want to. The GIS, that's not the GIS team's job to help with each of the step-by-step processes. The GIS team's job is to help the field with geospatial data and to get appropriate geospatial data back. And again, I focused really hard on GIS here, but I hope as you listen, you can understand that this is also true with asset management and safety management systems and so on. These are very much not designed in a way that's going to help the field do what it does. It's designed to help the people who are in the office who have that particular problem and who own that aspect of the business. That's who they're built for. And that's good. That's okay. We want that because we want that business owner to have a platform that they can use on their own to manage their processes and data, customize their processes and data, and integrate their processes and data. So with all that in mind, why do we keep on tilting at windmills, right? We keep on saying things like, I want to convince the field teams of the value of geospatial data. Heard this over and over again at the Esri user conference. And I understand why people want to do that. They want to show the field teams how important this is. But the field team is going to determine how much value the geospatial data that you bring to the table gives to them. Providing them more education is not going to be what convinces them of the value. Providing them more value will convince them of the value. So it's really all about how does this apply to those field teams. The GIS team spends hours and building and customizing the apps that field teams might have to use. And that's a challenge because the GIS team and the field team both think differently and are in different parts of the business. So a better principle for building apps and customizing apps and workflows that they might do is to push that to the people who are closest to the problem, and that is the field team. So we're spending hours and hours building, but it might not be worth it. And one of the comments that I heard at the user conference was, that when you're talking to the field team, you should just do them a favor, whatever that favor is, even if it seems trivial. The example that she uses, if you want to, turn a field purple just because it needs to stand out a little bit more, just make it purple because they've got to feel like you're responsive. Great. But if you're doing something trivial to show them that you're responsive, but your platform is literally built in a way that doesn't do some of the most important things that they need, then are you really helping them, or are you just showing them that you want to help them? So we keep tilting at windmills like this, but we're actually fighting a mismatch. The field teams don't need to be convinced of the value of geospatial data. They need to be supplied with the right geospatial data. They don't need you to build workflows for them. They need to be able to build workflows that support your needs because you have geospatial needs to get from them. So they need to build things that will give you what you need, and also that leverages the information that you can provide to them. And they don't need you to do them any favors. What they need to do is have a way to manage their own destiny in a way that's going to enable both them to be more productive and to enable you to not have to spend a lot of time working on things for them. I'm going to make that last one just a little bit more concrete. Imagine there's a person out in the field and they say, look, all I want you to do, the favor that I want from you is a little video walkabout of the transformer before they actually start to do anything. Just a little video walkabout. It's just a safety thing. I'd feel better understanding the context, knowing their environment, making sure there's no traffic issues. Just give me that little video walkabout. Are you going to want to change the table that you're working on, or the layer that you're working with to accommodate a video of that sort? What kind of priority are you going to give that? Aren't there better things for you to be doing? But if they have a place where they can say, this is my process, and in my process, I'm going to drop in a video, and you can ignore that, isn't that a better outcome for both of you? So we need to stop tilting at windmills, and we need to not fight the mismatch, but instead recognize it and do something about it. And one of the things that I think we need to understand as well as we're pushing forward with this is not just where we are now, but how we're going to deal with emerging technologies like AI. I'm going to focus on AI predominantly here because that's what so many people are interested in and so on. But I think it's true of any new technology. We never know what's coming next, and there's going to be a bunch of new stuff that comes out next. So with that in mind, I'm going to show you a video. Normally I wouldn't show a video during a presentation, but they say a picture's worth 1,000 words. And I figure this is about 2 minutes long. It's about 30 frames a second. You can do the math on how many images that are. It's a lot better than hearing me talk. The narrator is an AI. The narrator is speaking to us sometimes, like at the very beginning, she's talking to us, and at other times, you'll hear her talking to Landon, the person who's here in the video. So expect both those sides of the AI to be communicating with us throughout the next 2 and might be 2.5 minutes. I forget exactly how long. So this should work. If it doesn't, I'm sure I'll be notified very quickly. Here we go.
Take a look with me at what the future holds when our field worker puts on his smart glasses with camera and microphone and gets started with his AI-guided experience in Fulcrum. We've arrived at pole 1734. Please look at the top so I can scan for issues.
Sounds good.
I've already guided him to the right power pole. Now I'll capture some information so he doesn't have to, still under his control, of course. No visible defects in insulators or other features.
I agree, log it.
I can help him remember what he needs to do.
Guy wire tension is good.
Okay, but what about the guy wire covers?
Oh, right. Covers look good as well.
Got it. Ready for the pole itself.
Let's do it.
The pole tag should read 1734. It appears to be defective. Do you agree?
I agree. It's missing the 3.
Noted. Also, some cracking, but no major defects. Do you agree?
I agree. Log it. Hammer sound test.
There's more to all this than data capture. I help capture the right data with minimal effort, seeing what he sees, guiding him through the process.
Hammer sound is good. Probing below the soil line.
Just like I can help field workers with their jobs, I can keep the office informed of relevant field information.
Northern quadrant might need a second look. What's the SOP for reinspection below the soil line?
The manual says that potential defects should be reinspected and remediated within 30 days. Should I alert the office that pole 1734 should be reinspected using a shovel along with a pole tag replacement?
Yeah, do it.
The pole's inspected, the status is logged, nothing was missed. This is the future of Fulcrum. We're creating an AI-guided experience for every field worker. Last inspection of the day, pole 1735, 50 meters northward up this street.
Metal or wood?
Metal.
Sounds good. I'm going to put my belt in the truck and walk over.
You're due for a water break, too. It's 87 degrees.
Good call.
Excellent. So hopefully that helps you understand what a vision of AI fieldwork could be. And I need to point out that this is, at this point, a vision. There's a lot that is not built out here. The industry needs to catch up to what this kind of vision could look like. For example, the glasses are not available that would be suitable for fieldwork. We've been talking to Google and Meta about what might be, how we might be able to incorporate their glasses. They're not ready yet. But this is where AI is going. If we can create that AI experience, then we are going to be making life better and work much more productive for a lot of field workers out there. But the question is, where is the data and process information so that the AI can act in this scenario? The AI did a lot of things based on knowledge of what Landon was supposed to do, and there's additional information that they could take advantage of to make sure that it was done correctly. I should point out, two major types of what I call sanity checks. The one of which was shown in this video. One of them, it was a process sanity check. Okay, you checked the guy wires. You told me that the tension looks good, but what about the covers? Unless the AI knows the entire process, how's it going to know to ask about the guy wire covers? It needs to know the whole process. And the other one is a data sanity check. So if you're measuring something, let's say that this person is measuring the pipe, and the pipe is 24 inches above the floor, but he says 24 centimeters, then the AI needs to understand, okay, it doesn't look correct based on previous inspections, let's say. Or maybe there's another situation in which the field worker says, okay, the temperature gauge says 32 degrees. And the AI can say, okay, but it's August and you're in Texas. So is that centigrade or Fahrenheit? And he says, oh yeah, it's centigrade, sorry. And she says, okay, I'll do the conversion for you, no problem, I got it. And then plugs in the 90 some odd degrees it would be in Fahrenheit. That kind of data sanity check can only happen when you've got a view into where all of the data resides for the process, so the field worker can get information about whether or not their answers to questions actually make sense. So the problem, the question is, where does all that data and process lie? And the answer right now, unfortunately, is everywhere, because all of the different platforms that all of the different teams use are independent of each other by design, right? Remember, this is by design. The EAM team has a business owner, and that business owner needs a place to standardize processes data, customize them appropriately, and integrate them with other platforms. But the field worker is typically out there engaging in individual steps of processes, all of which rely on information from other platforms. And they're doing it not using a platform for themselves, but using a mobile app. Maybe they got Maximo Mobile, right? Because Maximo is the EAM, and they've got Maximo Mobile because the enterprise asset management team says, this is what I need from the field, right? Not necessarily how can I help the field, but this is what I need from the field. So they impose their thought process on what needs to happen, and they give Maximo Mobile to the field worker. And the GIS team, uses one of the Esri tools like field maps to say, okay, well, here's what you need to give us. Here's how you capture that information. They make it as easy as possible for the field worker to give them what they need, but it's still a separate tool that's being used to give that platform what that platform needs, not something that is helping the field team out. So they may be juggling more than one mobile app in order to execute a single step in the process. And because frequently that's a complicated thing to do, they'll actually revert back to paper. Maybe they'll revert back to a spreadsheet. In a good way, in a good case, they may type stuff into a spreadsheet, and once that spreadsheet is filled out, then they'll submit it, and some spit and baling wire process will load the data into the appropriate applications. In a bad situation, they'll take it down on paper and then transcribe it to the spreadsheet and then do uploads and stuff. It's complicated. And the more complicated you make it for the field worker, the less productive they're going to be, the greater likelihood there is going to be of data errors or incompleteness, and the less timely that data is going to be. And that's just for step one. All of the other steps are in the same situation. So the problem here is that when we are looking for where the data is going to be stored and the process is going to be managed for the field worker so that an AI or other technology can take advantage of it, the answer is everywhere. It's in this fragmented environment, and that makes things extremely challenging. And in fact, it's actually worse than what I just described, because I was talking about this as if there were only one application for each type of process, but that's not the case. There's also, the Access database under Jenny's desk, and Tommy's got a spreadsheet that he uses to communicate with this customer. And we were actually talking to a customer just recently about their enterprise asset management, and they said, yeah, we've got an EAM, but we've actually got two, because there is an acquisition we made recently of a company that does water. Their EAM is really great for water stuff. We don't want to take it away from them. So we've actually got two. We've got one for everything else and one for water. When you consider that that's the situation we're in, look at the bottom, and you look at the bottom four pictures and say, for any one of these individual kinds of processes, where is that data located and where would I apply AI? The answer is, again, everywhere. And because you're applying AI to these individual fragments of data and process, you're also even applying different AI technologies to each of those data and data elements and chunks of process. because maybe the EAM application was built by one vendor and the GIS application was built by another, and they use two different vendors, two different artificial intelligence vendors to support their AI endeavors. So it gets incredibly complicated. And the reason it gets incredibly complicated is that there's no platform for the field to work with. And that's where we get now finally to the implications for the architectures that we need to deal with. If we have a very complex and siloed environment that is extremely challenging to work with for the field, it's time for the field to get its single field platform. Some people think it's a little funny. It's like, oh, the solution to having too much technology is not to add more technology. But I'm not doing that here, actually. There's already technology being used out in the field. It's just that that technology is highly fragmented and not built for them. Whereas if you have a platform for the field, that dramatically simplifies your architecture, because now all of the steps that need to be managed are managed in one place, and they can typically be managed by the field team that is closest to the problem. Adding in that video walkabout that I talked about earlier can be done inside the single field platform, and if nobody else cares about it, nobody else has to know about it. The single field platform can gather information from all of the other platforms, just like you're supposed to do, right? That's what the platforms are there for, is to be the source of truth for each of those different parts of the organization. So get the information from them, including the GIS, including the EAM, et cetera, and execute the steps. As you execute those steps, or at the completion of those steps, depending on business requirements, you can push the information that you capture in the field back out to them, so they're made up to date. You're giving the field something that everyone else has already had for a long time, and the field has not had, and that is a platform for them to standardize, customize, and integrate their processes and data. The market category here is relatively new. People simply haven't been focused on this problem very much. There is a research director named Lynn Schneider at IDC, though, who talks about, especially with location and geospatial intelligence oriented requirements, that when you're trying to execute a digital transformation strategy where field operations in particular need to be streamlined, a location-enabled field process and data collection platform is a transformative alternative to outdated methods. She talks about include what I call the bolt-on problem that we just talked about a minute ago, where there's a separate field app for your EAM and a separate field app for your GIS and a separate field app for your safety management system. And also for another outdated method is trying to create custom apps that are going to work across all of those platforms. That's simply, that kind of homegrown solution is usually too painful, too rigid, too difficult to change, and therefore doesn't really work for the field either. So if you're interested in that, we have a copy of this IDC report on our website. It's not very long, but it's very clear about the specific benefits of having a field platform. Now, I talked about AI. I agree, I said up front that this is not just about AI, it's about any additional future technology that comes into play and the field needs to work with. But I'm going to just talk briefly about how we plan on achieving our AI vision using our field platform strategy. From a data collection perspective, we're already extremely well on our way. If you've not heard of it yet, Audio Fast Fill and the upcoming in beta Photo Fast Fill are both highly productive ways to use your voice to fill out a form and execute a workflow, or to take a photo of something like a nameplate and get all of the data off of that nameplate and potentially other information as well, and load the form without having to do additional work, allowing the AI to do the work of figuring out what needs to go into each place. We are currently testing something called Data Insights, which enables people to ask normal questions to Fulcrum. And because Fulcrum has a view into the work that's being done, Fulcrum can pull back and give answers about, where my team is today, how far along they are in their processes, what else needs to be done today, what kind of work is being done in the field. Ultimately, not soon-ish, but we have not. This is on our roadmap. This is now in testing. The ability to do real-time quality assurance and anomaly detection, those things that I called sanity checks earlier, those are next to be on the roadmap. Following that, the ability to create an interactive and guided field workflow, not necessarily with glasses yet, because again, we're not sure when the glasses are going to come on board, but being able to provide people that interactive and guided field workflow, we think will make people much more productive if they're new to the organization or new to the particular type of work that you're doing, or the piece of equipment is new or what have you. And also will ensure that even the old hands who are used to doing this kind of work, they see what they expect to see as they're using the tool to the platform to be able to execute their work processes. And then finally, that vision that I showed you earlier in the video, that kind of fully hands-free artificial intelligence and artificial reality enabled field process, that's going to be our ultimate goal. And frankly, I say our ultimate goal, by then things will have changed, and that's fine. But this is our North Star for achieving our AI vision right now. And it all depends on having a place for the processes and data in the field to make our field workers more effective. And one of the things that's really critical about a platform generally is that because very few field organizations do just one thing, then the platform should accommodate all of the different kinds of field activities that we're involved in. So inspections of various types, performing maintenance. This is a fairly common thing that's in an SOP. That SOP, standard operating procedure, can be digitized so that people understand exactly what process they need to go through. Other processes such as vegetation management could be also have their own standard processes or processes that people need to go through in order to achieve them. And then finally, safety, which if you're interested in the safety culture, creating a culture of safety, then safety needs to be embedded within all of these processes. But then there are some specific processes like confined space permitting and tailgate talks, which are just very directly and specifically related to safety. So incorporating all of these into a single field platform, choosing a platform that enables you to incorporate all of these various different types of processes, some of which are data collection, some of which are process management, all of that together is a really critical aspect of selecting and using a field platform appropriately. So just a moment on Fulcrum as a field process management platform. We know, our customers know very well, and they tell us that field teams struggle with inefficient tools, and that these tools frequently cause more frustration than they do actually help. And as a result, we have focused all of our energy on providing a field-first platform. Literally everything that we're concerned about starts with the field. There may be other beneficiaries of what we do, but they're beneficiaries of what we do because the field is a beneficiary of what we do first. That's why, for example, when we applied AI, we didn't apply AI to building workflows or building apps. It's already easy to do that, and saving 30 minutes or an hour or 2 days on building an app is not nearly as important as saving 10 minutes on each pole when we've got a 60,000 pole inspection requirement, right? That's what matters first. What can the field do? So our field first platform, we're always focused on boosting productivity and streamlining operations. The goal, pardon me for 1 second, sorry. Clearly I need to get off so that we can wrap it up, right? The goal of Fulcrum is to use this field first platform in a way that helps the field standardize, customize, and integrate its processes and data. And the impact that we've seen, what our clients tell us, is, 1 more second, sorry. That's how you can tell it's a live performance. The impact that our clients tell us is that if they invest $1,000 with us, they're going to see between $8,000 and $18,000 in return. That's based on that productivity boost and being able to sometimes enter new markets and a whole variety of different reasons that they get that kind of ROI. The 2 to 5 hours saved per employee per day, 25% increased capacity. Those are the ways, some of the ways that they achieve that return on investment. So with that, I would like to open the floor for questions. I think I can, yep, okay. There is a question box here, and I would like to ask you to enter your questions into it. I see there's already a couple. We have about 15 minutes if we take that long. So please feel free to ask me any questions that you've got right now. I have one question coming in that says, I don't think we can standardize. It's not really a question, it's a statement. I don't think we can standardize on a single field platform. There's not a lot of context here, but if I understand where the question's coming from, it's a pretty common question, which is, for example, if there is no, if there's no standard, if we haven't selected a field standard yet, then I'm not sure I can get everybody onto the same field platform. That's what I think they mean by that. And if I try to go out there and say, well, I'd like you to standardize on this, then I'm going to open up a rat's nest of other people arguing with me about, well, no, I want this field platform, or I want that field platform, or what have you. First of all, I don't think there's a huge number of different field platforms out there to choose from. So you can look at some specific requirements around things like geospatial capabilities, being able to create a workflow that has automatic alerts or automatically reaches out to GIS platforms or EAM platforms and so on, being able to do that kind of integration work, et cetera. You can look at some of the specific requirements to say what would make sense there. But it's totally true that you won't get rid of political issues by having more technological solution potential. So what I would suggest is that you do some pilots and consider how you would, excuse me, and consider how you would find a platform to standardize to, right? So if you have a number of processes that you're engaged in that are across different departments, let each department kind of figure out what it's trying to accomplish. And before you get too far, just continue to have the dialogue about which ones are really serving your needs the best. And eventually you will find, just like we've seen this over and over again with technology, you'll have a bunch of different options. People will try different options. And as IT looks at it and says, this is getting out of control, I've got too many options all at the same time within the company, we need to standardize, you'll find a platform to standardize to. So it's a messy answer, but I think it's a realistic one. Start, pilot, let it get a little bit messy, and then figure out how to consolidate onto some individual platform. Another question is, if I can't get a field, if I can't get a field platform yet, can I at least consolidate the data? The answer here is yes, but with a significant caution. I'm picturing here someone saying, well, I'm not going to get a field platform, but I have a data warehouse. Can I put all of my field data into the data warehouse? Yes, of course you can. The challenge there, typically, and I'm speaking from experience with business intelligence and analytical tools over the past 20, 25 years, we've seen architectural challenges come up over and over again, and they got kind of worse as we entered the big data era, and I don't think they're getting significantly better. The challenge is that the data tends to be difficult to alter once you've decided what the structure needs to be. So this is similar to the way that the GIS is not designed to change its formats, its data structures very often. A data warehouse frequently has a particular way that data is going to come into the warehouse. So it's very challenging to make changes in the warehouse as requirements change in the field. So you will get some benefit from trying to consolidate that, but it's probably not going to be extremely rapid. It'll help you do analysis and things of that sort, but it won't help you support the field as well. So can you get some AI work on that? Yeah, your AI might be able to tell you certain things like, various readings look like an anomaly. So those kinds of data anomalies that I talked about will be aided by having the data consolidated into a data warehouse. If you don't have the process data in place, then you still have the challenge with the field team not being able to control their process, right? You're still losing out on the productivity. So yes, you've been able to do analysis much more quickly. That's great. But the fact that you've saved 2 days worth of work on analysis or a week's worth of work on analysis is great, but you're still not saving that 10 minutes per person per poll on 60,000 polls. Like on a truck that costs you $240 to roll out the door, on a per hour basis. That's a huge miss. Not having the process available, not having the process contained by the field in a way that the field can control it, not having the ability to apply AI to the process involved in these workflows, that's a big mess. So yes, you gain some benefit from consolidating the data, but it's not an ideal situation. I'll just say it that way, I guess. I have another question about how we would integrate with different types of systems. I've actually got a couple here. One of them is about the work order management in enterprise asset management systems, since I've talked a lot about that. And then another is about SCADA. I never know how to say that, honestly, which is about combining hardware and software together to kind of manage and monitor what's happening. Those are two kind of different kinds of integration. They're both really important. So let's talk about them in turn. I'll start with the EAM side. With an enterprise asset management system, very often that is the platform that defines what the work order is and the tasks that make up the work order, right? So that's the system of record for that. So the first step that happens is the work order gets defined, not an individual instance of a work order, but the definition of what a work order is happens in, let's say, Maximo. And then the tasks that are associated with that work order would be defined in Maximo as well. There is a process to reflect what that looks like in Fulcrum. So there's a work order that's canonical, if you will, in Maximo. There's an artifact, a workflow in Fulcrum that reflects that work order that's from Maximo. And then each of those tasks, which are typically at the task level only in an EAM, those tasks are a reflection of what's in the EAM, as well as the detailed process by which those tasks might get completed. So again, the EAM doesn't worry about, for example, safety, right? They worry about the asset type and all that kind of good stuff. They worry about the maintenance history and that sort of thing. So the task in Fulcrum includes things like pull the information about the maintenance history and the requirements from the EAM, execute or create the process by which you do the appropriate safety activities to do a lockout, tagout, or do whatever kind of safety checks you need to for the type of environment you're in, execute on the tasking within the task itself, the detailed steps within that task, and then once you've executed that task, send something back to Maximo to say this task is now complete, and then lather, rinse, repeat to finish all the tasks within the work order. Once all of those tasks within the work order are done, typically it's, as I understand it, I haven't actually seen this myself, but as I understand it, it's kind of a dual thing, right? The EAM sees that the tasks are complete, so it says that the work order is complete, and Fulcrum will also send back a signal basically to the EAM saying this work order is complete. Now, when you need to make when you need to make changes, obviously there are going to be changes that reflect in both systems, but there may be some changes that the field needs to do itself. That video walkabout is I keep coming back to it today. That video walkabout might be something that the field team needs and the EAM does not. That doesn't need to flow back to the EAM, right? That can be something that the field team itself manages. Additional information from to and from the safety management system, additional information to and from the GIS could also happen within that workflow, independent of what happens in Maximo. So the field is managing all of the steps in the task that the field cares about and puts that in the field's control, but it has to match up with what the EAM and with what the GIS are expecting. So that's the EAM side. It's kind of high level. Hope it wasn't too complicated or whatever, but that's one piece of it. The talking about SCADA, there are a lot of cases. I'm going to make this a little bit more general. There are a lot of cases in which we need to integrate with sensors or other kinds of automated systems in order to perform our tasks appropriately. Some of them are really simple. Like I do a demo that, I'm a marketing guy and I don't know anything, and I was still able to put together this demo that will automatically call out to a weather service nearby. So you say, this is my location. It collects it automatically from your GPS on your phone, and it will call out to a weather service, and it will come back and say, 72 degrees, 30% cloud cover, whatever it is. I wish it was 72 degrees today. It's not. It's November. With other systems, we've had, for example, the temperature sensor on a drill bit for doing geographic drilling, like oil drilling. The temperature sensor on the drill bit coming back into Fulcrum to make sure that it was correctly tracking that, and that the system was capturing that information at the same time that we were doing other parts of the inspection. Pressure gauges in, or pressure sensors in pipes, voltage sensors on poles or in lines. There are a variety of different ways that we connect into a lot of different kinds of sensors. That's typically done using some kind of web service integration, but we have an extremely powerful API that can work with almost any kind of sensor you can think of that would enable you to capture the information that's in those sensors, and potentially, if there needs to be a push back to some kind of system to trigger a reading or something like that, that can be done as well. So I know that's kind of general as well, but there are a lot of different kinds of what I call field tech requirements that Fulcrum needs to integrate with in order to manage a full field process. I hope that was clear enough, and if it wasn't, then please come back to us and ask us more questions. If I can't read this whole thing, sorry. There we go. If I'm collecting data in a specific area, can I loop data collection to collect multiple entries, or would the field team need to make multiple entries? For example, if I were collecting chairs in a room, would I need to make multiple entries for each room, or can be configured to make just one entry? So I think what you're talking about here is, do I need to have an individual record for each chair, or can I have a record for the room and then child records, if you will, for each chair in the room? And the answer is that there are reasons to choose one or both of those, and there's a number of ways that we can accommodate this kind of requirement. The simplest way to think about what you just talked with the chair example is to have a single record for the room, if you want it that way, and then have what we call a repeatable inside that record, and a repeatable would collect the data for each chair. That's a pretty common way of doing it. Another consideration is that sometimes it's not that neatly hierarchical, or you're doing multiple things in the room, and one of them is chair inventory, and the other is outlet testing, right? So in that case, what you might do is you might have a single, what we call an app, right? But it's in this case, it's almost used more like a data store. That single app would be rooms. You might never actually see that. There might never be a field worker who sees that on their device. But that rooms app holds data about the rooms that you're in. And then you would have an app for chairs and an app for outlets. And in the app for chairs, you could say, which room am I in? And you select the room that you're in, and then you could have repeatables underneath that for all of the chairs within that room. And then you do the same thing for outlets, where you say, okay, well, I'm in this room. Which room am I in? You select, okay, I'm in room floor stand B, and in floor stand B, I see the 3 outlets that I need to select to inspect. So there's more than one way to handle it. Some of that depends on the way that you want to handle it. Some of that depends on the way that it would be shared, not just on the way it would be collected, but on the way that the data would be shared. There are implications there a little bit, and how it would be reported on. An individual app with multiple sub-records in it, multiple repeatables in it, is great for reporting in many cases. But in many cases, it's not as good for sharing, because it's more tightly coupled to that outer app, if you will. Again, I hope that made sense. I'm not sure it did. But please come back to us and ask us if you need to. We're at the top of the hour, so I thank you very much for your questions. If we didn't get to yours, don't worry, we will be back in touch. Please come visit us at fulcrumapp.com again, and thank you very much for your time today. I know you had other stuff you could do, and I appreciate you sticking through this with me. Take care.